Good evening, Stats 243 folks. I want to answer just a couple lingering questions on last week's homework, just in case you're going back or using a late pass and you want to make sure you have them done. And this one was proposed in the email. And then I want to just talk a little bit about this coming week's homework. We will have our Wednesday night session face to face, but I thought I'd give you a little overview. So, first, one question from homework 1.2. And this was number 7. And it gives you data, ages, and number of students. And my example is 15 to 18, 19 to 22, 23 to 26, 27 to 30, 31 to 34, and 35 to 38. And this is 2, 6, 5, 6, 8, 9. Right? And then it says, based on the frequency distribution above, find the cumulative frequency for the class with the lower class limit of 27. So the first thing I notice is that this is the class with the, oops, that was not what I wanted to do. There we go, let's try that again. Um, so this, this is the class with the lower class limit of 27. So we want the cumulative frequency. So I would go all the way up to here. So my cumulative frequency columns would start at 2. 2 plus 6 is 8. 5 plus 8 is 13. 13 plus 6 is 19. So my answer would be 19. So hopefully that clears you up on that question. Let's look ahead for a second and just take a look at what our next week entails. So we are this week, the week that started today, and again, we will meet again on uh, uh, Thursday, not Thursday, Wednesday. But what do we have going for this week? First of all, we have a lab. So lab 1 is due. And then we also have a homework that goes over measures of central tendency. So these are things like the mean, which is the sum of all your data points divided by the number, right? This little squiggly line means add them up. So if I had a data set like, so if I had a data set like 2, 4, 6, 8, right, then my mean would be 2 plus 4 plus 6 plus 8, and there are 4, so we divide by 4, right? Commonly known as the average, something we are all pretty familiar with. Right? The mode is the thing that happens the most. And the median is either the middle point or the average of the two middle points. So these are our measures of descriptive statistics. We also talk in this chapter about our standard deviation, and this is a super important concept, standard deviation. Past we had things like the range to describe the spread of a set. But you could see that I could have a set that ranged from 0 to 10 and look like this. You could also have a set that ranged from 0 to 10 and look like this, either all on 0 or all on 10. So you can see that those are two very different sets, you know. So we come up with a measurement called the standard deviation to tell us how far away, on average, each point is away from the mean. So to calculate that by hand, you would take each data point, subtract the mean from it. This is the symbol we use for mean, or we also use this symbol if it's a sample. This symbol is for the whole population. Then we divide by our sample size. If we're working with the sample to make a better estimate, we divide by our, um, our sample size minus 1. We take each of these points and we add them up. We square them, the difference, right? And then we divide. So let me give you a quick example of them. Suppose your whole set, everything that you cared about was 2, 4, 6, 8. We just talked about this. This is going to have an average of 5. Right? So I would take every point in the set and I would go 5 minus 2, or sorry, 2 minus 5, my point minus the mean, square it, plus 4 minus 5, square it, plus 6 minus 5, square it, plus 8 minus 5, square it, and then, since this is a population thing, I would divide that all by 4, and then I would take the square root of whatever that number is. So, I would have 9, that's 3 squared, plus 1, plus 1, plus 9 again, 4, whole thing square rooted. Notice this part in the square root, right here, that has a name and it's called the variance. We use this symbol for variance. So this would be 20 divided by 4, square rooted, also known as the square root of 5. I'm sorry. So, sorry. The variance would be 5, and the standard deviation, variance, the standard deviation, which is the square root of the variance, would be the square root of 5. Okay, so that's how you calculate that. Again, it's the average distance away from the mean. So we have this 2, 4, 6, and 8. 5 is here, and on average, they're each about the square root of 5 away from 5. Right? Now, the square root of 5, I don't know what that is off the top of my head as a decimal, but it's 2 point something, something, something. And these are each about 2 away. Now, you might be wondering, like, oh, why does she do it so hard? We can see that that's 1 away, and that's 2 away, or 3 away. And that's 1 away, and that's 3 away. Negative, negative. Why doesn't she just add those up and take that average? Well, if you do that, you see when I add it up, I get 0. Because this cancels with that and that cancels with that. That's the function of the average. So that's not successful. Well, then you might think, well, why doesn't she just take the absolute value? So that you would go, okay, this is 1 and that's away and that's 3 away and that's 1 and 4. And then take 8 and divide that by 4 and get 2. And say, okay, that's 2 away. That's the average away. Well, the problem with this is if you take an absolute value of a function, you might remember this from algebra 2, you might not, but it's real pointy at the end here. And that causes problems when we take another absolute value and add the two together. Then we end up with a function that looks like this, with this big flat part right here. And that means there's no absolute minimum. And without an absolute minimum, then we can't do the calculus behind making this all work. So if we square it and then take the square root, a squared function looks like this. And if I add another squared function to it, I get another squared function. And there's always an absolute minimum. So that's a kind of a hand-waving, flashy way of saying it's important that we do this because it makes the rest of the calculus later work for us. And absolute values, that type of measurement just is not as successful as we move along. So anyway, and they're really close. You know, this was 2 and this is 2 point something something. So it's going to be pretty close together. right, well, so that's the standard deviation in that chapter. Let's see. You'll want to do most of these things using some sort of technology, which I will show you on Wednesday. But just real quick, when you're entering it into a calculator, and I did recommend, strongly encourage the TI-84 for this class, or some sort of TI or graphing calculator. It becomes really important towards the end of this class, but it's really helpful right here too. If I go to Stats button and let the list and the edit, then I can just enlist one, edit all my data, and then I can choose calculate, and then one variable stats, and then that's going to give me my mean and my standard deviation for a sample and my standard deviation for a population and a whole bunch of other statistics. Just the calculators give it all to me, including my median and a number of things. So I strongly recommend that you take a look at the TI-80 3, 84, CE, the 89, any of those that you can get for a good price. It will pay off dividends throughout this term. I'll also show you how to do this on Minitab on Wednesday, so check into the Wednesday video to take a look at that. And we'll be doing the homework problems for those. Hope you guys are all having a great night, and I wish you the best of luck.